Every day, we wake up, walk around, travel, work, and live our lives without really thinking about the giant planet carrying us. But have you ever stopped and asked yourself a simple question? What is the actual shape of the Earth beneath our feet? Is it truly round, as science says? Or could it be flat, as some people still believe today? Thousands of years ago, humans looked at the horizon, the sky, and the land, and tried to understand the world with the tools they had. Many ancient cultures imagined the Earth as a flat surface, a giant plate floating in the universe. Some believed the sky was a dome. Others thought the edges of the world hid magical seas and mysterious creatures. Even today, the flat Earth theory has followers. They believe the Earth is shaped like a disc, with the North Pole in the center and a massive ice wall around the edges. According to this view, the Sun and Moon are small, moving in circles above the Earth like spotlights. They argue that the horizon looks flat, that people don't feel the Earth spinning, and that some space images could be edited. To many, it's a theory built on questioning, curiosity, and sometimes distrust of big institutions. But questioning is not the problem. Humans should ask questions. The real power lies in searching for answers through observation, logic, and evidence. So let's look at the scientific story, the one supported by physics, astronomy, and centuries of observation. The Earth is a sphere. Not a perfect sphere, but a slightly squished one. It is a bit wider at the equator and flatter at the poles. But how do we know this for sure? First, there's the simple act of watching a ship sail away. When a ship travels over the horizon, it doesn't just shrink evenly into a tiny dot. Instead, it disappears from the bottom first. The hull vanishes, then the mast, then the very top of the sail. This is exactly what you would expect to see on a curved surface as the ship follows the bend of the Earth. If the Earth were flat, the entire ship would just get smaller and smaller until you couldn't see it anymore. Next, let's travel back in time over 2,200 years to ancient Greece. A brilliant scientist and librarian named Eratosthenes made a groundbreaking discovery using nothing more than sticks and shadows. He noticed that on the same day, at the same time, a vertical stick in the city of Syene cast no shadow at all, because the sun was directly overhead. But in his own city, Alexandria, which was hundreds of miles to the north, a stick of the same height cast a very noticeable shadow. This difference in shadow length could only happen if the surface of the Earth was curved. Using the angle of the shadow and the distance between the two cities, Eratosthenes was able to calculate the circumference of the Earth with astounding accuracy. He measured our planet using just his mind and some basic geometry. Then there's the view of the night sky. As you travel from north to south, the stars you see change. Head south, and familiar constellations like the Big Dipper will sink closer to the northern horizon, while new stars you've never seen before will rise in the south. The Southern Cross, for example, is invisible from most of North America, but becomes prominent as you travel toward the equator and beyond. If the Earth were a flat disk, everyone, no matter where they were standing, would see the same dome of stars above them. The fact that our view of the cosmos changes with our location is powerful proof of a spherical world. Now, let's talk about gravity. Gravity is the force that pulls everything toward a center of mass. For a massive object like a planet, that force pulls from all directions equally toward the center. Over billions of years, this constant inward pull naturally molds large celestial bodies into spheres. It's the most energy-efficient and stable shape. That's why everything else we see in the universe on a large-scale planets, moons, stars are all round. It's the universal law of physics at work. And of course, in our modern age, we have the most direct evidence of all, photos and videos from space. For over 60 years, we have sent satellites, probes, and astronauts into orbit and beyond. They have sent back countless, unambiguous images and live video feeds of our planet. We can see its curvature, its continents, its swirling weather patterns, and its clear spherical shape from multiple angles. This isn't just one orthophotos, it's a massive, continuous stream of data from agencies all around the world, confirming what scientists have known for centuries. The roundness of the Earth also perfectly explains the cycle of day and night. If the Earth were a flat, stationary disk, the sun would illuminate the entire surface at once. Everyone would experience daytime and nighttime simultaneously. But that's not what happens. Instead, as the spherical Earth rotates on its axis, different parts of the globe are turned toward or away from the sun. This rotation is what creates sunrise in one part of the world while another experiences sunset. It's the reason we have time zones, and why you can call a friend on the other side of the planet who is just waking up while you are getting ready for bed. Modern technology and travel are fundamentally built on the reality of a spherical Earth. When an airplane flies a long-distance route, pilots don't fly in a straight line on a flat map. They use what are called great circle routes, which are the shortest paths between 2 points on the surface of a sphere. These routes look like long, strange curves on a flat map, but they save immense amounts of time and fuel in reality. Our entire global positioning system, or GPS, relies on it. A network of over 30 satellites is constantly orbiting our spherical planet. Your phone or GPS device works by receiving signals from multiple of these satellites and calculating your precise location based on their positions in orbit around Earth. The complex math that makes GPS work would completely fail if the Earth were flat. The same goes for weather forecasting, global communication networks, and even the internet infrastructure that allows you to watch this video. Our modern world is built, quite literally, on a global model. So, if the evidence is so strong, so overwhelming, and woven into the very fabric of our daily lives, why do some people still believe the Earth is flat? It's a complex question, but part of the answer lies in human nature. We are born curious. We are driven to question the world around us. And in an age where we are flooded with immense amounts of complex information, it's natural for some to seek simpler explanations. When official sources can seem overwhelming or untrustworthy, questioning can sometimes turn into deep-seated doubt, and that doubt can pave the way for alternative beliefs. The flat Earth idea offers a simple, easy-to-visualize model in a world that often feels complicated and out of control. But science isn't about believing blindly in what you're told. It's the complete opposite. It's about testing, observing, measuring, and repeating experiments. It's about building a picture of reality that consistently matches the evidence, not our personal feelings or pre-existing beliefs. Every piece of evidence for a round Earth can be tested and verified by anyone with the right tools and curiosity. In the end, whether the Earth is flat or round isn't just a trivial scientific question, it is a story about human curiosity and our relentless journey for knowledge. It's a story about how far we've come, from ancient observers measuring shadows with sticks, to modern explorers orbiting thousands of kilometers above our heads, looking down on our home. And through all this accumulated knowledge, one thing becomes undeniably clear. The Earth is round, dynamic, alive, and unbelievably beautiful. Our journey to understand it, to question it, and to ultimately see it for what it is what makes us truly human. Stay curious. Keep asking questions. And always search for the truth, because that's how we grow. Thanks for watching.